Okay, integrating by u substitution, we have an indefinite integral of u to the n du. Remember that the reason it's called indefinite integral because the limit of the integral is missing. We do not have a lower or upper limit. So that's equal to u to the n plus 1 divided by n plus 1 plus a constant. N cannot be negative 1 because if we substitute negative 1, that will make the denominator 0, and eventually that will make the integral undefined. So let's look at our first example. We have x squared multiplied by x cubed plus 7 raised to the 4th power dx. That's equal to, so in this case we have to make a choice. So I have rewritten the problem and I just moved the x squared next to dx because I'm expecting what's inside the parentheses to be my u and what's outside to be du. So u is equal to x cubed plus 7. The derivative of u is du. The derivative of x cubed plus 7 is 3x squared dx. Now taking the solving for x squared dx, we have to divide both sides by 3. Lastly, we go back and we substitute x cubed plus 7 is, remember that that's the value for u, and x squared dx is simply du over 3. X squared dx is du over 3. Lastly, we take the constant out, which is 1/3. U to the 4 du. Now it's really easy. We're using the power rule. Adding 1 to 4 becomes 5, dividing it by 5 is u to the n plus 1 divided by n plus 1. And we had 1/3, we bring it down, multiply by 1/5, u to the 5 plus a constant. So at this time, we write 1 divided by 15, and the value, instead of u, we are substituting x plus 7 plus the constant, and we are done. Okay, let's try the second problem. I gave you a moment. Remember that we are making a u substitution, so find your u. Okay, so in this case, we don't have parentheses, instead we have a radical, so we still let u equal to be 1 plus x cubed. And you could also see that if you take the derivative of x cubed, you're going to have x squared on the numerator, which is really the derivative of the x cubed. So let's let u equal to 1 plus x cubed. Differentiating u is du, differentiating 1 is 0, differentiating x cubed is 3x squared dx. Remember that if we are taking the derivative of u, we always write du. And if we are differentiating x, we always writing dx. We are solving for x squared dx. The reason that we are solving for x squared dx because we have x squared dx here. And this is a substitution method. So we write our integral, and instead of x squared dx, we just write du over 3. So that's the same thing as 1/3 du divided by radical u. Remember that u is the same thing as 1 plus x cubed. Now we bring the constant outside, and we bring the u from downstairs to upstairs, from denominator to numerator. So the exponent in the denominator is negative, but when we move it up, it's positive. Excuse me. When you bring it up, it becomes negative. So anytime you're moving an exponent from downstairs to upstairs, or upstairs to downstairs, or numerator to denominator, denominator to numerator, the sign of the exponent changes. In this case, u was raised to the 1/2. So when we move it up to the numerator, it became u to the negative 1/2. Lastly, at this time we have u to the n du, so that becomes u to the n plus 1. So negative 1/2 plus 1 is 1/2, and dividing it by 1/2, and we bring the constant from downstairs to upstairs becomes 2. And now we have 2/3 times square root of 1 plus x cubed. We simply substituted the value of the u, which is 1 plus x cubed, plus a constant. Okay, let's try this problem. Again, this problem can be done by a couple of different ways, but we are using only u substitution in this lesson. So if you look at the problem closely, you have something raised to the power, in this case is sine x raised to the 3rd power, multiplied by cosine x dx. So this looks like u to the n du. So obviously we have to let u equal to sine x. The derivative of u is du, the derivative of sine is cosine x dx. Going back, we have our original problem, we copy it down, and that's equal to, now sine x is just u, and because it's raised to the 3rd power, we're also raising u to the 3rd power. Now simply integrating u to the 3rd, and we're getting u to the 4th divided by 4. Finally substituting sine x for the u, we're going to get 1/4 sine to the 4 x sine x to the 4 plus a constant. Okay, finally the last problem looks a little bit different from the other ones. So I give you a moment, please try this problem. So I'm pretty sure that you are thinking of letting u equal to x plus 5, because that's a moment ago we said that we have u to the n. So it seems like it's raised to a power. But then you probably are wondering, how would I find x here? Because x is not the derivative of what's inside. But let's see what happens. So we're going to, it looks like that, and I put x in red. So you just have to remember that. Again, we're just not going to change our strategy at this time. We're going to let u equal to what's inside the parentheses. So u equal to x plus 5. And differentiating u becomes the u, x becomes the x, 5 becomes 0. And we are also, we have an x here, and before substituting we want to make sure that we solve for x here. So to solve for x, we have to solve this equations in terms of x, and that is that subtracting 5 from both sides. So x is equal to u minus 5. So all the time when you have an expression that is something looking like this, you want to solve u in terms of x. Going back, that's our x. X plus 5 is the value of the u, and that's raised to the 4th power. Now we are also substituting for x u minus 5 in the next step, and x is equal to u minus 5 multiplied by u to the 4th raised to the 1/2. So in other words, the square root of u to the 4 is simply 2, because 4 raised to the 1/2 is same thing as the square root of 4, which is just 2. And now we are distributing u squared to u, and that becomes u to the third, and u is also u squared is multiplied by -5. We're going to get -5 u squared. Finally, we integrate u to the third becomes u to the fourth and raised to the fourth power minus u to the third becomes u to the 2 becomes u to the third divided by 3. And lastly, we are substituting 1/4, and instead of x, we are substituting x plus 5, and this is raised to the fourth power minus 5/3, and remember that u is equal to x plus 5, and it's raised to the third power plus a constant. Okay, that's it. I hope you enjoyed it. In the next video, I will do integration by part, and we're gonna do some other cool substitution. Have a great day.